Hi guys, welcome back. It's me again, Mike.
And I'm Michael.
And Luke. So today we will teach you the basic functions and operations of function generator and oscilloscope. Let's go!
Bounds.
The objective of this video is to help the students familiarize the operation of function generator and oscilloscope.
Function generator usually a piece of electronic test equipment or software used to generate different types of electrical waveform over a wide range of frequencies.
So we have here a function generator. So the model is WFG-2100, and we have here the power button and the light indicator. So if the power button is pushed on, the light indicator will light up. So next is we have here the frequency knob. So this frequency knob is used to adjust the frequency. So the number indicated is the frequency amount. So next here is the frequency range. So it serves as the multiplier to the frequency chosen at the frequency knob. Next, we have here the symmetry knob. So this knob is used to adjust the pulse duty cycle. Here we have also the DC offset. So this DC offset is used to match the DC voltage at point of signal injection. So right here down below we have the invert button. So if you press this invert button, the waves will invert. And now next we have here the functions for selecting the kind of waves. First we have here the square wave. Next here is the sawtooth wave. And lastly the sine wave. So next here we have the amplitude knob. So this knob is used to adjust the magnitude of the waveform. Here below we have the 20 decibels button. So if you turn this button on, the signal power of decibels will set to 20. Next we have here the different outputs. First we have the pulse output. Next we have here below is the VCF or the voltage controlled frequency. Lastly we have here the output with the 50 ohms resistance.
Oscilloscope is a laboratory instrument commonly used to display and analyze the waveform of electronic signal.
Hello everyone. We're here to tackle the switches, the knobs, and the use of the oscilloscope. So first is the power, the main power switch of the instrument. When this switch is turned on, the LED is also turned on. So we have here. Next is the intent, controls the brightness of this spot or trace. So we have the intent here. Brightness. And next is the focus for focusing the trace to the sharpest image. Here, the trace rotation, as you can see, there is a hole right here. This trace rotation can be used by using a flat screw to rotate to enable this line to be straight, to be parallel with the axis. Next is the filter. So we have the filter right here. Filter for ease of waveform viewing. So on this part, we have the channel 1 and channel 2 vertical inputs. Right here, we have the AC, GND, and DC. So this is the AC coupling. Next is the GND. Vertical amplifier input is grounded and input terminals are disconnected. And for the DC, it is the DC coupling. Next is the voltage per division knobs. Select the vertical axis sensitivity from 5 millivolts per division to 5 volts per division in 10 ranges. So we have the values right here. 10 values to choose from. Next is the vert mode. This function enables us to choose channel 1, channel 2, dual, and add. On the channel 1, oscilloscope operates as a single channel instrument with channel 1 alone. So this is the channel 1 right here. Next is for the channel 2. Switch channel 2. The oscilloscope operates as a single channel instrument with channel 2 alone. So channel 2. So next is the dual. The oscilloscope operates as a dual channel instrument, both channel 1 and channel 2. So as you can see, we have two lines right here. And last is the add. The oscilloscope displays the algebraic sum of channel 1 and channel 2, or the difference of channel 1 and channel 2. Next is the alt chop. We have right here the alt chop. When this switch is released in the dual trace mode, the channel 1 and channel 2 inputs are alternately displayed. When this switch is engaged in the dual trace mode, the channel 1 and channel 2 inputs are chopped in display simultaneously. So we have right here. Next is the channel 2 invert. It inverts the channel 2 signal when the channel 2 INV switch mode is pushed in. The channel 2 input signal in add mode and the channel 2 trigger signal pick off are also inverted. So we have this source switch right here. It is to select the internal triggering source signal and the EXT trig in input signal. The slope right here. By selecting the slope, if it is on the positive, the triggering occurs when the triggering signal crosses the triggering level in a positive going direction. While if it is negative, the triggering level in negative going direction. You have the trigger mode right here. In auto, when no triggering signal is applied or when triggering signal frequency is less than 25 Hz, sweep runs in the free run mode. So that's the auto. Next is the norm. When no triggering signal is applied, sweep is in a ready state and the trace is blanked out, used primarily for observation of signal less than 25 Hz. So as you can see, there's no any result in norm. Next is the TV-V. This setting is used when observing the entire vertical picture of the television signal. Next is the TV-H. This setting is used when observing the entire horizontal picture of the television signal. We have the level right here to display a synchronized stationary waveform and a set start point for the waveform. So if it is on the positive, the triggering level moves upward in the display waveform. And if it is negative, the triggering level moves downward in the display waveform. Time-based area. First, we have the time per division knob. Its sweep time ranges are available in 20 steps from 0.2 microseconds per division to 0.5 seconds per division. So you can set the time per division vertically oriented. As you have noticed, we have a small piece of metal right here that has a hole. This terminal delivers the calibration voltage of 2 volts peak to peak, 1 kHz positive square wave, and it is called the CAL.
At your first glance, function generator and oscilloscope seems like a very complicated machine because of its too many functions. But if you take time learning each functions, in no time, you will be able to use the machine without complications.
We learned that the function generator gives the signal to the oscilloscope and the oscilloscope displays the waveform output.
The main difference between the oscilloscope and the function generator is that the function generator can't display the signal while the oscilloscope can display the signal.